All right, testing. Testing. It seems good. All right. Hello. Welcome to our 491 lab one. This is group one. Stanley. Where I'll go over today. I'll be going over 7 and 8, but our group members will have a slightly different version. This is the final version where we have more comments in them and a slight difference on how certain questions are saved. So question 1, 2, 3, 4, 5, 6 will be covered by my lab partners, and I'll just go over a little bit. Just has more comments. Question 5, we changed how it's saved, so we basically set up a figure and then saves to the figure, so it doesn't conflict with our questions 8 animations because it's sometimes like loading that, so we isolated them. How the saving method, same thing we did with 6. You can see that right there. All right, now on to 7. So this is to generate the different impulse graphs, different function graphs. We were given, these are all given, all of these. We can calculate each one of them based on them. All right, so looking at this, all right, a bit farther down, unit signal, what we learned, unit signal ramp, all of these. These are basically the functions for them. So the step units, you also have to do continuous step. Yeah, continuous step is just follow through. There you go. This is just setting it up. These are the formulas, the functions and the formulas. There you go. It should correspond there. Then this is the impulse, so it should go like this, exactly like that, and then bam. Basically, this just splits it. The impulse compared to continuous just splits it, makes dots. All right, same thing. Continuous ramp, RT equals T times UT. T times UT. There you go. And then RN is just N times UN. There you go. So it will, instead of be continuous, it will be a dots, right? All right. We generate a square wave, both an impulse and the continuous. You can see here. There you go. That's what it should look like. All right. Now we plot them. Basically, most of these are the same. We have a subplot. We plot it, show the grid. You can see the grid. Set up the labels, set up the titles, set up the limits, the y limits. All right. Same thing for all of these. All of them will look similar. The continuous unit step, the discrete time step, should like this. Here we go. The impulse is here. The discrete time impulse is here. Matching what we have, we learned in class. Alright, so we have the ramp. It should go, yep, very good. Yeah, so these two are corresponding, which is perfect. All of these are similar. Now we get to this part. This part just saves it automatically when you run the file. Alright, now on to question 8. This is the fun part. Alright, I'll wait for a bit to run. Alright, so we have, similar to question 1, we have a time vector set up. We define our FM, FC, the carrier frequency, the message frequency, the amp for carrier, and modulation index. Alright, we have our base signal, which is the amp multiplied by a sine wave for the messenger signal. And our carrier signal will be the AC, the amp, carrier amp multiplied by a cosine wave based on the frequency of carrier. And then, so we will generate a clean wave based on that. Let me find that. It's hard to see, but it should be in there for now. I will run the animation a bit. So we add a noise. So we have a targeted noise ratio of 15, and we will generate a noise signal based on that adding the clean and the noise, so it will be a bit fuzzy. You can see that there. Alright, now we generate a 4-panel plot for the 4 different values. Basically, we have the carrier. Basically, this sets up the figure for saving here. Yeah, right there. This one, we have multiple subplots. This is just the title. We have the carrier subplot, the messenger subplot, the clean AM subplot, and the noisy AM. So you can see this is carrier wave, this is the message wave, this is the clean one, and you can see how there's some noise to the noisy AM one. Alright, and then this is the saving this plot. Alright, I'm gonna run this program. So this is not needed anymore. We had some issues with the animations taking the previous figures, which is not good. Alright, it popped up. Here's the animation. You can see it. We'll show once it's alright. There we go. Anyways, well, we will show you this one. Basically, we set up the animation, the figure for the animation. We set up the axis, the grid of it, set the title, add the labels, and then we set up the plot for the clean and the noisy. You saw it at first, and then we set up a lower bound and lower bound and an upper bound for our axis. Our axis, and then we apply them. Anyways, so we will use a sliding frame, so it would make it look a bit animated, even though it's just multiple frames on top of each other. Anyways, our number sample is based on our time vector. Our window length is based on the roughly 12% of our number of samples with a minimum of 20, so it doesn't look weird. And then we start with an index of 100 frames. So we have a for loop running multiple iterations, so every time it runs, it updates the clean segment and the noisy segment, and updates the updates the x horizontal axis, so it goes up, and then we render it, and we add a timeout to wait for it a bit, so it does not all instantly show up, so it looks like an animation. So every time it loops, it's like an update, as you can see at first. Now, and then we restore everything after it's done, like to the full view, so we can see this right here. We just plot it all out. There you go. And then we save it. There you go. And now we have the interactive GUI. So this is just for saving. We set up the figure, the axis, have the multiple plots, the carrier plot, the messenger plot, the AM plot, the messenger ampage plot, and then legends. So all of these are for, let me click this. Alright, all of these shows the numbers, generates a number for each of the different lines. This one for AM, this one such as, and then we go down. This is a slider. You can change these. You can mess with it how you like. Play with it. And then we have a save plot button. Whatever you make, you can save it pressing this button, and it will show up on the left side. Mine has already showed up because I ran this before. Alright, and this callback. This function just ensures that this thing will update live. So whatever you do, it will have a response instead of freezing. Alright. Now we have onto the challenge demodulator. So for this part, we have a failsafe. Basically, if the values are missing, we will generate them again. So basically it checks if the values are there. If not, just generate them again. here you go. All right, there's two methods to how we demodulate. First, we have the envelope method. We use a Hilbert transform to create a analytical signal of the noisy AM. There we go. And we take the magnitude, just the magnitude, which should be the same as the original in this function. And then we remove the DC offset since the real envelope always sits above 0. There you go. And then we use a low pass filter to reduce the ripple right there. And then we use a Butterworth LPF with cutoff slightly above the message frequency to remove unwanted high frequency. There we go. These are. And then we normalize it so our output matches the expected AM value. There we go. There we go. And method B, we have coherent synchronous. Similar, we multiply the carrier by a low cosine wave, cosine of the carrier frequency FC. You see this right there. And then we shift it by multiplying by 2 cosine, which gives both the baseband term and the high frequency term around 2 FC. Right there. Similar, we use a low pass filter to remove the high frequency 2 FC out of here. There you go. This is what it does. And then we, similar to the other one, we remove the DC offset. I guess we skipped some step, but the essentials are the same with the previous one. Same method, just slightly different way of doing it. And then we normalize it. Right there. Right here. And then we generate our MSE for the envelope method and the coherent method. And then we plot. Similar to all of the other plots, we set up the plot, set up the axis, set up the plot 1, plot 2, plot 3, following the original message, and then updated envelope and the coherent result. And then set up the legends. Set up these ones. These are the little boxes of legends. Set up the title. Set up the label for X. Hard to see, but it's there. And then we save it. There you go. It should be saved on the left side. There you go. And then here we have the local function. This should go last. Basically, this updates our, I don't know where it went. Anyways, it updates our GUI. Remember this one? This one helps update it live. Every time you scroll it, it will change dynamically. This one's the function that helps it. Basically, it reads it, runs the signal again, and updates the data, and then updates the display. Alright, thank you.